Heat transfer is the movement of thermal energy from one place to another due to a temperature difference. Heat always flows from hot objects to cold objects, never the other way around. There are three primary modes of heat transfer that we encounter in everyday life: conduction, convection, and radiation. Conduction is heat transfer through direct contact. When you put a metal spoon in hot coffee, heat travels up the spoon through the metal, making the handle warm. Convection involves heat transfer through the movement of fluids like air or water. Warm air rises from a radiator, creating circulation patterns that distribute heat throughout a room. Radiation is heat transfer through electromagnetic waves. The sun warms the earth through radiation, sending energy across the vacuum of space without needing any material to carry the heat. These three modes of heat transfer work together in many real-world situations. Understanding each type helps us explain how thermal energy moves through our environment and affects our daily lives. Conduction is the transfer of heat through direct contact between particles in a material. The efficiency of this process depends heavily on the material's thermal conductivity. In conduction, heat flows from the hot end to the cold end through molecular vibrations. Particles with higher kinetic energy transfer their energy to neighboring particles with lower energy. Materials with high thermal conductivity, like metals, transfer heat efficiently because their electrons can move freely. Insulators like wood or plastic have low thermal conductivity and resist heat flow. Convection involves heat transfer through the movement of fluids, liquids, or gases. This process can occur naturally through buoyancy forces or be forced using fans or pumps. In natural convection, heated fluid becomes less dense and rises, while cooler fluid sinks, creating circulation currents. This creates a continuous cycle of heat transfer. The rate of convective heat transfer is described by Newton's law of cooling, which states that the heat transfer rate is proportional to the temperature difference between the surface and the fluid. Radiation is unique among heat transfer methods because it doesn't require a medium. Heat is transferred through electromagnetic waves that can travel through vacuum, like the heat we receive from the sun. The amount of radiation emitted depends on the object's surface properties, particularly its emissivity and its temperature. This relationship is described by the Stefan-Boltzmann law. Common examples of radiation include feeling warmth from a fireplace, microwave ovens heating food, and thermal imaging cameras detecting body heat. Understanding these three heat transfer methods is essential for engineering applications like designing efficient engines and insulating buildings.